Hello, this is Mr. Stansbury. This is the second half of the 17C notes on the rectangular hyperbola. Okay, so we just did an example similar to this one, but we're going to try this one. It's set up a little bit different. This is going to be a little trickier for some of it, but that's all right. First question, what's the vertical asymptote? Okay, so that's the asymptote that goes up and down. So basically, vertical asymptote is asking what can't x be. Okay, so that's when we want to know when x minus 1 is going to equal 0, because we know we can't have that equal to 0 because we can't divide by 0. So add 1 to both sides and we get x equals 1. So the vertical asymptote is x equals 1. Okay, horizontal asymptote is this one here. And really, when you get x's over other x's, what you do is you're just going to take the coefficients, the numbers in front of the x's, and you're just going to take this here is going to be your answer. So it's going to be 4 over 1, so that's going to be y equals 4 is going to be your horizontal asymptote. Okay, if this was, say, 4 over 4x plus 2 over 2x minus 1, then it would be 4 divided by 2. It would be y equals 2. Okay. X-intercept is when y equals, the x-intercept is when y equals 0, right? So let's do that. Let's do 0 equals 4x plus 2 over x minus 1. I'm going to do that as 0 over 1. So we cross multiply and those go away because 0 times anything is going to be 0. So it's basically just going to be 4x plus 2 is going to equal 0. So subtract 2 from both sides and we get 4x equals negative 2 divided by 4. X equals negative 1/2. There's our x-intercept. And then the y-intercept is just going to be when the x's equal 0. So let's try that. So we get y equals 4 times 0 plus 2 over 0 minus 1. So y equals basically 2 over negative 1. So y-intercept is at negative 2. Okay, and then we're going to sketch a graph of the function. All right, so let's put a graph up there. Let's take our important information and graph it. All right, so first thing, vertical asymptote, x equals 1. So make a little dotted line here. Ooh, sorry, you get the idea. At x equals 1. And then our horizontal asymptote's at y equals 4. And really the easiest way to do this is just to graph our x-intercept and y-intercept, and we'll be able to get a good enough idea what the graph looks like. So it's going to cross the x-axis at negative 1/2. And then it's going to cross the y-axis at negative 2. So there's a couple of points there. So that means this graph is going to look something like this-ish over here. And then it's going to mirror image that over here. So it's going to look something like that. Okay? So roughly that's what our graph is going to look like. Okay? All right, we'll look at one more example and we'll be good. All right, this is similar to example 3 from page 561, which has an experimental breeding colony of ninja cats set up, and the size of the colony at time t years is given by n equals 20 minus 400 over t minus 10. So that's just our crazy formula for how many ninja cats there's going to be. And apparently ninja cats don't like dogs. So, and anyway, this only holds true for the first 8 years, so from 0 to 8 years. Okay, so what was the original size of the colony? So that's when t equals 0, right? So let's do that. Let's see, I believe I have a graph going over there. Yeah, let's do the work over here. So that's when t equals 0. So number of ninja cats is going to equal 20 minus 400 over 0 minus 10. So that's going to be 20 minus, let's see, 400 divided by negative 10. It's going to be negative 40, so it's 20 plus 40. So the number of original ninja cats is 40. Okay. Sorry, 40. 60. 60 ninja cats. All right. So what's the size of the colony after 3 years? So now we're going to just simply put 3 in for t, and away we go. So n equals 20 minus 400 all over 3 minus 10. So that's 20 minus 400 over 7. And let's bust out our calculator, make our life easy. All right, so let's just put this in. 20 minus 400 divided by 7 gives us, what did I do? Oh, it's 400 divided by negative 7. So let's change that. Negative 7, there we go. So about 77 cats. So n is about 77 ninja cats. All right. Same thing for after 8 years. N equals 20 minus 400 over 8 minus 10. So that's going to be 20 minus 400 over negative 2. So that's going to be not NO, but N equals 20. Let's say we got the double negative, so it's going to be plus 400 divided by 2 is 200. So 220 ninja cats after 8 years. Okay. How long would it take the colony to reach 100 ninja cats? So then that's where we're going to put the 100 in for the N. Okay, so let's try that. See if we have enough room. I'll just make enough room. All right. So 100 equals 20 minus 400 over t minus 10. So now again we're just going to solve for t. So first thing I'm going to do is subtract 20 from both sides and get 80 equals 400 over t minus 10. And really whenever I get a fraction equaling a whole number of some sort, I like to just put that over 1 and I just do cross products. So 80 times t minus 10 should equal 400 times 1. So basically we get 400 equals 80 times t minus 10, right? 400 equals 80t minus 800. So add 800. Oops. Add 800. There we go. To both sides, and we get, let's finish that off over here. 1200 equals 80t. So we divide both sides by 80. And we get that t equals, let's figure that out, just make sure, 1200 divided by 80 gives us 15. So that means it's going to take 15 years. So 15 years to reach, we did something goofy then, to reach 100 ninja cats. All right, I see what we did. What I did wrong here. This is supposed to be a negative 400, so that's negative 400. Negative 400 plus 800 is 400 divided by 80, which will give us 5. So it'll take us 5 years instead of 15 years. So let's just erase that one. There we go. 5 years to reach 100 ninja cats. Okay. And then last part of this section here is to graph this thing. Okay, so let's do this in time, in years. So there's 1, 2, 3, 4, 5, 6, 7, and it only goes up to 8, so we can do that. We could, looks like we could do it by half years, but that's right. And then let's make this ninja cat population. Let's do 10 20, 40, 60, 80, 100, so forth and so on. And then now we'll just graph some points here. All right, so original population was 60 ninja cats, so we know we have a point there at 0, 60. After 3 years, we were at 77, so 3 is at 77. 8 years was 220, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be about up. 8 years is going to be about up here. And then let's see, 5 years is at 100. So it looks like our graph looks something like this. Oops, I missed. But you get the idea. All right, that looks, should be a little bit more curved there, but you get the idea. All right, so that would be our graph for Ninja Cat. So it's growing exponentially fast. All right, that's it. You should now be able to say that I can find x-intercepts, y-intercepts, asymptotes, and graph rectangular hyperbolas. If you have any questions, please ask. Thanks.